Hi, we're working on energy and wavelength problems today. So here's the problem in front of us. A green line in the hydrogen emission spectrum has a wavelength, remember wavelength is lambda, of 486 nanometers. What is the energy of one photon of this light? And then we have a couple of constants right over here that will always be available to you. So the first step in this problem is recognizing which of our equations to use, and that's why I highlighted as I read to find the lambda and the E. And the relationship between lambda and energy, or wavelength and energy, is E equals hc over lambda. So the next thing I want to do is I can start plugging in my constants here. And so as you can see, I plugged in our constant H and C, complete with units and carefully copying the scientific notation. Now all that's left is the lambda here, and I need to make sure my units are going to match. So in the constant that I have here, the speed of light, I notice that the units are in meters, and the units on my wavelength that were given are nanometers. So I need to do a quick conversion of nanometers into meters. So here's what that looks like. I'm going to write down my 486 nanometers. I'm going to know or remember that for every 1 times 10 to the 9th nanometers, which are very tiny, that will make up 1 meter. And so when I multiply that, I get 4.86 times 10 to the negative 7th meters, which plugs right in here as the denominator. Now, be careful as you plug this into your calculator. Common pitfall is to not use parentheses around each of these numbers. Multiply those two and then divide by the denominator, but use parentheses around everything. Check that your units are going to cancel out. So I have seconds in the numerator canceling with seconds in the denominator, meters numerator, meters denominator, and I'm going to be left with joules right here as my final unit. So when you punch that into your calculator, your answer is, again, here's my problem that I just solved right here, and the answer is, with correct significant figures, 4.09 times 10 to the negative 19th joules. As a common sense check, we're often going to see that on the order of 10 to the negative 19th. It's a very tiny amount of energy, because it's an amount of energy of 1 photon, which is on the order of an atom, which is very, very, very tiny. So there you have it, energy and wavelength and 1 unit conversion all into one problem.